So, in this video, I would like to talk about some special cases, okay? If water, it is sometimes a solvent and it is sometimes a product or reactant in a reversible reaction, okay? So if it is a solvent, it will be large in excess, right? Because we use a lot of water to dissolve a small amounts of solute. So at this moment, concentration of water would be very large and, when compared to that of the solute. So we treat it as a constant because it is relatively unchanged. So it will change, but the extent is very small. So we treat it as a constant and we ignore the water, okay? However, when water is a product and a reactant, the concentration changes significantly. It is not a lot larger than the reactant or the other solute. So we need to calculate the water and we need to put it in the equilibrium expression, okay? We need to put it in equilibrium expression, okay? When it is a product or a reactant. So now let's look at this question. This question would be class practice 40.7, okay? Class practice 40.7. So now the question asks us to write an expression for Kc prime of backward reaction. How can we, so for the backward reaction, it would be like this. So the equation for backward reaction. So now let's put down the backward reaction first. It will be like this, because we just reverse the equation, okay? So now we reverse this equation and we can write down the expression of backward reaction. So Kc equals okay, in this case, water is a reactant and it is not a solvent. It is not a solvent, so the concentration will change. So we need to take it into consideration, okay? So we write down the expression and we find out the value of Kc. If we reverse the equation, so how will the Kc change? Do you still remember? Kc will be 1 over K, this one. It will be 1 over Kc. Why is it 1 over Kc? Because the original Kc would be like this, would be Ch. Original Kc would be like this. So can you see that now we have, it is actually the reciprocal, which is 1 over K prime C would be 1 over Kc. Okay, can you see that? So now we can just substitute the value of Kc, which is 1 over 4 equals 0.25 and done. Okay, so now we have completed the first part. Part A we have done. And then we are going to do part B. So now let's put down the equation first. So this would be the equation for part B. Okay, now we put down the information that we have, which is 1 mole of ethyl ethanoate. Ethyl ethanoate is actually this one. Okay, so we have 1 mole. 1 mole of water, 1 mole of water. Okay, so why don't we do not have to consider the volume. Okay, now let me put down this first and I'll explain to you. Why don't we have to consider the volume? Because if this 2 would be, we change 1 to 1 over V, where V equals volume. If we use 1 over V, this is 1 over V, then this 2 will also over the volume, right? So we have something, we have over V, over 1 over V, over V. Can you understand this? Because no matter what these are, these can be any number because this is actually the number of moles. Number of moles, we can find it simply. Perhaps, let me show you. This is x, this is negative x, okay? Negative x, positive x, positive x, 0, 0. Understand? So this is x, this is x. 1 minus x, 1 minus x. But if we we use the, but if the number of moles is divided into by volume, 1 over x over v, x over v, okay, x over v. So we have x over v times x over v over 1 minus x over v times 1 minus x over v. Can you see that? So actually these volume cancel out each other. Can you see that? So it is not necessary for us to consider the volume. We just use the number of mole for our calculation. That would be fine. Okay? So we have 0.25. The Kc equals x times x over 1 minus x times 1 minus x. So 0.25 and x squared minus 2x plus 1 equals x squared. So now we can just multiply it into the brackets. 0.25 minus 1. So x equals -1. Can it be negative value? No. So we reject this value. And or equals. So x equals 0.3333. So now we can find out the number of moles. Number of moles H2O equals ethyl ethanoate equals 1 minus. Okay, and the number of moles of the exit and equals number of moles of this one. Actually, this is called ethanol, and they are equal to x, right? X. So x equals. Okay, now we have completed this question. Okay, we have found out the number of moles of all the species, each species in equilibrium mixture. Okay, understand? So now we have completed the question.